Assalamualaikum dear students. Hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena, Haque, assistant teacher of Science, National Ideal English Medium School, Day Shift. Dear students, today I am going to take a chemistry class based on chapter 6, and this is the part 2 of the chapter 6, and the name of the chapter is Concepts of Mole. So let us move forward to today's topic, Concepts of Mole and Chemical Counting. And today we will start with molar volume of gas. The volume of that 1 mole of a gaseous substances occupy is called the molar volume of gas that of that gas. That means this is the definition of molar volume. Now we will know that 0 degree temperature and 1 atmospheric pressure together is called the standard temperature and pressure or standard condition. This one also you have to learn. That means what is called standard condition. 0 degree temperature and 1 atmospheric pressure together is called standard temperature and pressure, and in short form we will use in this chapter, that is STP, standard temperature and pressure. And there like the Avogadro number, the volume of 1 mole gas in a standard condition is 22.4 liter. That things you have to memorize, 22.4. Like in standard condition, the number of atom, number of molecules and number of ion of a substance is constant, that is known as Avogadro number. Like that in standard condition, the volume of 1 mole of any gas is also constant, that is 22.4. And here we will get some formula that we will use in our mathematics term. If N is equal to the mole number, W is equal to mass in gram, V is equal to volume in liter, and capital N is equal to number of molecules, and M is equal to molecular mass, then small n is equal to W by M. That we have to learn, that also we have to learn, that small n is equal to V by 22.4 and small n is equal to N by Avogadro number 6.023 multiply with 10 to the power 23, and this is the Avogadro number. And these three, by using these three formula, we have to solve some problems that is given in your book. Now here these problems is given, we will not solve this problem, you will practice these problems, and the next page 2 problems also at home. Now we will solve another problem which is written here. The problem says how many molecules are there in 1 liter sulfur dioxide gas at standard temperature and pressure. Now come to the solution. At standard temperature, 1 mole sulfur dioxide is equal to 1 multiply sulfur atomic mass is 32 plus there is 2 atom of oxygen, oxygen atomic mass is 16, that is the 64 gram. 32 plus 32 is equal to 64 gram sulfur dioxide is equal to, here we know in 1 mole there is 6.023 multiply with 23 nong of sulfur dioxide molecule is equal to the 1 mole molecule's volume is 22.4 liter. Now sulfur dioxide at STP, that means at standard condition. Now in STP. Dear students, I am using the short form of standard temperature and pressure, but when you will do the math, you will write the full form. 22.4 liter sulfur dioxide gas contain is equal to 6.023 multiplied with 10 to the power 23 nong sulfur dioxide molecule. Now, therefore, one liter sulfur dioxide gas contain is equal to 6.023 multiplied with 10 to the power 23 divided by the volume of 1 mole, that means 22.4. That if you calculate, you will get the number 2.69 multiplied with 10 to the power 22 molecule. And like this volume is constant, the Avogadro number also constant, then time, if we subtract the Avogadro number with the volume, we will get in every time the same number. That means in every gaseous matter 1 liter have the same number of molecule, and that is the answer of this problem. Now come to the next one. Next problem is, what is the volume of 10 mole oxygen gas at standard temperature and pressure? Dear students, that is problem which is taken from 114 page, and here solution is here. It is given the mole number is 10. N is equal to 10, and we require to find the volume. And to find the volume, that means V is equal to what? According to by using the second formula, we know small n is equal to V by 22.4, and n we know 10, and volume we have to find out 22.4. That means 10 multiply 22.4, that is liter, because we have to find out the volume. So volume equal to 224 liter, and this is the answer of this problem. So students, now come to the next page, next lesson, mole and molecular formula. The relation between mole and molecular formula, the quantity in gram determined when we express the molecular mass of a substance gotten from its molecular formula is called 1 mole of that substance. For example, molecular formula of water is H2O and its molecular mass is 18. Therefore, 18 gram is called 1 gram molecular mass water or 1 mole water. It is clear here that mole is also the gram molecular mass. Molecular formula provides some other information too. For example, in the case of water, now come to first one, H2O is water, that means CO2 is carbon dioxide, H2O water, then if we are take H2, that is hydrogen, then CO, carbon monoxide, like this, by the formula we can determine the name of that substance. The formula of 1 molecule water is H2O. Now come to the next point. The formula of 1 mole water is H2O. Now next one, 1 molecule H2O contains 2 hydrogen atom and an oxygen atom. And fifth one, 1 mole H2O molecule contains 2 mole. That means if it is 1 molecule, that will be atom, and if it is 1 mole, that will be 1 mole H2O. That means water. 1 mole of water molecule contains 2 mole hydrogen and 1 mole oxygen. Come to next one. 1 mole water molecule, the mass of hydrogen atom is 1 into 2 is equal to 2 gram. The mass of oxygen atom is 16 into 1 is equal to 16 gram. Therefore, the total mass of 1 mole water is 2 plus 16 is equal to 18 gram. And last one, in 1 mole water molecule, the number of hydrogen atom is, we know that this is the Avogadro number, and 6.023 multiplied with 10 to the power 23 multiplied by 2 is equal to 1.20 multiplied with 10 to the power 24, and the number of oxygen atom is 6.023 multiplied with 10 to the power 23 and multiply with 1, because there is only one atom or 1 mole of water, 1 mole of oxygen, and that will be the same as the Avogadro number. And the number of water molecule in the 1 mole water, we know that is the Avogadro number 6.023. And students, that is the atom, that is the oxygen atom, and this is the water molecule. Number is same, but this is the different thing. That number is for oxygen atom and that number is from water molecule. Now come to the molar solution. This is the definition of molar solution. At a fixed temperature, if 1 mole solution is dissolved in 1 liter solution, then that solution is called molar solution or 1 molar solution. Dear students, this is the definition of the molar solution. This is the definition of molar solution, and we have already learn about the solution in our class 6 mixture chapter. The solution is equal to solute plus solvent. Solute plus solvent, which thing we will use to dissolve in the solvent, that is known as solute. And there is various types of solvent, that means water, acid, alcohol, etc. But in this chapter we will use as solvent most cases the water. In the most cases the water, because we know water is the universal solvent. Now come to the next page. In the next page there is, in the second para, this para is too much important for you. Number of mole dissolved in every liter solution at a certain temperature is called the molarity of the solution. That is the definition of molarity. That is the definition of molarity. We know the molar solution is at a fixed temperature if 1 mole solution dissolved in 1 liter solution. 1 mole solute dissolved in 1 liter solution, that solution is called the molar solution. And if the number of mole, if we do not know the number of mole, then what number of mole needed for every liter solution at a certain temperature, that is the molarity of that solution. Now come to next part, that is 2 mole solute is dissolved in 1 liter solution at a fixed temperature, then the molarity of that solution is 2. And if 1 mole solute dissolved in 1 liter solution, that molarity is 1. When 0.5, that thing you have to learn. When 0.5 mole solute in 1 liter solution, that is semi-molar solution. That is the definition of semi-molar solution, and that is very much important for your MCQ and knowledge based question. And if decimal 1 mole solute dissolved in 1 liter solution, that is known as decimolar solution, that is known as decimolar solution. I am saying again, the 0.5 mole solute if dissolved in 1 liter solution, that is known as semimolar solution, and 0.1 mole solute when dissolved in 1 liter solution, that is known as decimolar solution. Now we will learn a formula that is taken from physics, but we will use here in our chemistry, because physics, chemistry, biology are interrelated, and maths also. Now the formula is mass of solute in gram unit. Molarity of the solution is equal to molarity of the solution multiplied with volume of the solution in milliliter unit multiplied with molecular mass and divided by 1000. And in short form we can say it W is equal to SVM. W is equal to SVM divided by 1000, and here W is equal to the mass of the solute into gram unit. S is equal to molarity, V is equal to volume of the solution in milliliter, and M is equal to molecular mass of solute. Molecular mass of solute, not the solvent, molecular mass of solute, and that also, so W also for solute, M also for solute, and if we divide these three with 1000, we will get the W's value, and if we have any of three, that means WSVM, any of three, we can easily find out the next one by using this formula. Here I am saying again, W is equal to mass of solute in gram unit, S is equal to molarity, V is equal to volume of solution in millimeter unit, or then come to the next one, M is equal to molecular mass of solute, and we have to divide SVM by 1000, then we will get the value of W. And if we have any three of them, this means WSVM, among of these four, if we have any three, we can easily find out the next one. Now I will go for solving the problems related to this formula, and first we will solve the next page formula problem, that means page number 117's formula. How will you prepare 0.5 molar glucose solution in volumetric flux? Now come to solution. That is not solution of this solution, that is the mathematical solution. Come to the solution. Here given volume of solution V is equal to 250. This is the volume, 250 ml. Now come to molarity of the solution. Molarity of solution is equal to 0.5 molar and molecular mass that we have to find out. Mass of glucose C6H12O6, that the carbon atomic mass is 12, 6 multiplied 12 plus, that is number is 12 multiply 1 plus 6 multiply 16, because oxygen atomic mass is 16, and in total 72 plus 12 plus 96, and in total that will be 288, and molecular mass we find out in gram. So molecular mass of glucose is 288 gram. Now therefore 1 mole C6H12O6, that means glucose, is equal to 288 gram, and 0.5 molar solution there will be glucose C6H12O6 in 1 liter or 1000 ml requires is equal to 288 multiply with 0.5, and it will be 144 gram, and 250 ml solution requires 144 multiply with 250 divided by 1000 is equal to 36 gram. Now we have to write the answer by add 36 gram glucose in a 250 ml volumetric flask that will complete the preparation of semi-molar solution or 0.5 molar solution. Now come to the next problem, which is given in your book, page number 118. The problem is, what is the molarity of the solution when 10 gram sodium chloride in 250 ml solution? 10 gram sodium chloride in 250 ml solution, and we will solve this in alternative way by using the formula. Now come to the solution. Again I am saying this solution is mathematical solution, not the mixture solution. Now here mass of solute, that is W, is equal to 10 gram. There is written 10 gram. And next one is molarity, that means S, that we have to find out. Next one is V, volume of the solution. Sorry students, my pen is not working. Volume of solution that means V is equal to 250 ml. Now come to next one, that is M. M is equal to molecular mass. Molecular mass of solute, that is the M, capital M, that we have to find out here. And molecular mass of sodium chloride, then sodium atomic mass is 23 plus chlorine atomic mass is 35.5. So molecular mass is 58.5 gram. That is the capital M. Now we will solve the problem by using the formula. We know W is equal to SVM divided by 1000. This pen's ink also going. And W is equal to, or W is equal to 10 gram is equal to S, we don't know, we have to find out. V is equal to 250 ml and M is equal to 58.5 and divided by 1000. And if you calculate the calculation, you will get the result. The S is equal to 10 multiply 250 multiply 58.5 and S is equal to 10,000 divided by 14625, or S is equal to 0.68 gram. So we can write it, the molarity of the solution. So molarity of the solution is 0.68 gram. Dear students, I have finished my today's topic and this is your homework. You have to solve these three problems. The first problem is how much sodium chloride is there in a 5 liter decimal 2 molar solution, molar sodium chloride solution. And second problem is what is the volume of the solution in milliliter when 10 gram glucose is dissolved in decimal 75 molar glucose solution. Now last one is how will you prepare 100 ml semi-molar sodium chloride solution. These three problems you have to solve in your homework copy as homework number 2, and you have to submit on Saturday from 9 am to 3 pm. Dear students, I have finished my today's topic. Hope you have understood. You have to practice all the problems which is given in your book. You have to practice more and more and do the SW and submit it. Thank you. Allah Hafiz.